This is Andy Jaski with the CAPINC Kayak project. When we last left off, I had just finished refining my design using mass properties, a design study, in SolidWorks Flow. With the exterior hull finished, I now moved to designing the internal structure of the kayak. I already had the wood stringers created, but now I needed to create geometry to hold the stringers in place. Typically, this geometry would be simple flat frames cut out of wood. But because I had a 3D printer, I was not constrained to making simple flat geometry. I also wanted to use as little 3D printed material as possible. For this reason, I turned to Inspire, an optimization software, to reduce the amount of printed material needed. After importing my model into Inspire, I defined the design space for the software to add or remove material, shown here in orange. I also brought in the already designed stringers, but did not allow Inspire to modify them, because my intention was to keep their shape simple so I could cut them out of wood. After giving Inspire the area to add structure, and the geometry to keep in place, I then defined a series of load cases. As you can see here in this study, I defined multiple load cases, shown by the red arrows. Some to represent the kayak floating normally with the paddler, others for loading at the bow and stern, representing launching and landing on a beach, and also loading on the top to represent the kayak rolling. I then selected to optimize for stiffness and gave it targets for the amount of mass reduction. You may notice the organic look to the structure that Inspire created. This is because the software uses a bone growth algorithm that adds material in much the same way that bone develops. With this first run, I quickly noticed that while most of the recommended structure was good, I had forgotten to let the software know I needed space for the kayaker's legs and float bags in the bow and stern. I also decided I wanted a slightly higher resolution. However, even with this quick first run, I was able to get some insight into where I should be placing structure, so I quickly modified the design space to allow for the paddler and bags, and broke up the single study into multiple sections so I could use a higher level of refinement without taking a very long time to run. I started at the bow, following the same steps of defining the design space, creating load cases, and choosing what to optimize as before. The results are seen here. I imported the result from Inspire into SolidWorks as a graphics STL. Then I overlaid a solid interior section of the same area and carved away material until I had my finished part. I repeated this for all the front bow parts. After I had finished fully modeling the bow section, I imported those parts back into Inspire and ran a new optimization on the center and stern sections of the boat. I took the results from Inspire back into SolidWorks just as before, and finished modeling up the rest of the structure. The kayak frame was starting to come together, and while some of the Inspire guided structure looks logical, I do not think I would have come up with anything close to this design on my own. But pretty designs are worthless if they don't function. So to validate my final design, I turned to SolidWorks Simulation to run some quick FEAs to ensure my first outing would not turn into a swim. The results of the FEA showed that the kayak structure was more than capable of handling the load seen during use. To show the effect of using Inspire, I first modeled the internal structure as I typically would do, using flat cross sections. When comparing the two results, the difference is astounding. After having used Inspire to help guide the internal structure of my kayak, and then validating my design with SolidWorks Simulation, in the next video, I'll show how I took the design from the computer screen to the real world using 3D printing, and then finally assembled the whole design and launched.